I will say we're recording. Um, for this is a perfect example of what I was trying to show you with the little cubes. It's a shape. It's a rectangular prism, and I want you to imagine every shape that I give you that you can do this, that you can break it into little cubes and then count them. If you notice, this right here is technically the same thing than here at the bottom, which is the base, right? And it is measuring centimeters. It's 3 centimeters by 4 centimeters. So when you multiply that, what do you get? 12 centimeters. So the top of it, the area is 12, right? But because he has volume, that has height, we say that he has 12 cubes right there. You see those? There are 12 cubes on top. Does everyone see those? I have 12 cubes and I have 5 layers of those. So how many cubes do I have total? 60. So when we use that as area, we find that's where the formula, the area of the base times the height works. Because the area of the base is just 12, right? 3 times 4 is 12. And then you multiply it by the number of layers, which in this case is the height, which is 5. You get 60. 60 what? 60 cubic centimeters, right? And we say cubic because we're counting cubes now. We're no longer counting squares. We're counting how many cubes you can find in the shape, right? So using the same idea, let's go to these right here and find the area of those 3 shapes right here. No, the neighbor has to do it. That was adorable. Okay. There you go. Find the volume of all 3 of those figures. Darn. And I'm back. Okay, so area of the base times the height, right? When we're looking at a rectangular prism, where is the base? At the bottom, right? The what? At the bottom, yes, it's bottom numbers. So the base would be this one right here, right? So the area of the base would be only those numbers included over there. So 6 times 4, and then times the height of 5, right? So 6 times 4 is 24. 24 times 5, what does it give me? Sorry? 120 what? Cubed. Cubes. We're doing cubes, right? And then the next one is the same thing. Area of the base times the height. So the area of the base is 6 times 3, and then times 4, right? It's shaded. It tells you that's the base. So 6 times 3 is 18. 18 times 4, what do I get? 76. Centimeters, what? Cubed, yes. And the last one is super easy as well. And you're like, oh, this is so easy. I do them with eyes closed. Yes. I want you to get used to the idea. Oh. I don't know. I heard somebody say that, so I figured that was it. All right, 7 times 2 is 14 times 5. What does that give me? What? 70 centimeters cubed again. All right, so those are fairly easy, right? Those are easy. We're going to use the same concepts, area of the base times the height, for the following. We're going to go over here to our geometric land. Yeah. I'm listening. The height? What about them? Yeah, yeah. What about it? Yeah, you can multiply one by the other one by the other one, it gives the answer. But you just multiply numbers. You have no idea why you're doing that. That's why I show you with the little cubes. Why is it that we can multiply the length times the width to get the area, and then times the height to get the volume. You have to understand this. I don't want you to just multiply for no reason. It's like, oh, okay, that's my answer. You need to know why you're doing it. Cool? So use the formulas that way too. So let me show you over here, using that same concept, we're going to create a square that is this guy is, well, I forgot the measurements. It is 49, write it down, 49 by 68 and a half. So 49 by 68.5. Write it down. Don't do anything with it yet. Just write it down. Yes. Is that what I said? 68.5. Now I want you to notice, what kind of figure is this? Two-dimensional, right? And here's how I can prove that. You can hardly see it, right? If I move it, you can see the other shapes. What is the difference between them? Yeah? This one over here, the little flat one, is 2D, right? It has no height. It's just a flat figure. If we were all 2D people, all we will always see will be that. Lines are expand across or shorten, but that's all you can see. You can't see above them. Does that make sense? But we are not. We are 3D people. We can see all around us. We can see all the sides of each other. So that is one of the main differences between that. But I understand these are connected, right? To get the volume, you need that base, right? We're all about that base.
Oh, I was just about to say that.
I just heard that, so I don't know what it means. But um, so we wanted the area, find the area of that, and then I will give it a height. And then we're going to understand how the area is connected to volume. Because we start with an area, and then we end up with volume, right? Go ahead and find the area of that. It means everything.
What is it?
So for this one, it's a little bit difficult. Not difficult, it just takes longer because you have bigger numbers. Let me advise you, or just let you know ahead of time, that for the entire volume part, we are going to be using bigger numbers. So get used to that. The numbers were what? 49 times what? So we multiply. 9 times 5 is 45, carry 4. That'll be 72 and 4 is 76, carry 7, 63, and 7 is 70. No, that's wrong. 54 plus 7 is what? 61. And then we use that as a placeholder. 4 times 5 is 20, carry 2. That'll be 32 and 2 is 34, carry 3. 24 and 3 is 27. And then we add 5, 6, 5, 3, carry 1, 3. A couple of things on this, guys. I want to expand a little bit of why I like to use a dash instead of a 0. The reason why, because when I use a dash, it's easier for me to not get confused with the zeros that I get when multiplying and the placeholders. So if you use a little dash or a 0 with a dash on it, that makes sense. Does anybody know, by the way, why you use zeros there? Why we use placeholders?
So whenever like you don't confuse it. You don't put my computer. So you don't add. No, so you don't confuse it. That you can multiply.
Let me show you something that they should have taught you at the very beginning of middle school, of elementary school, when you started adding. When you multiply 12 times 4, what place is this in? Ones, tens, hundreds? Ones, right? What place is this in? Tens, right? So I have 2 ones and 1 tens, right? That's what I actually have. What place is the 4 in? In the ones. So when I multiply 4, which is in the ones, by 2, what do I get? I get 8, right? Do not mind what I'm going to do at the bottom. Just look over here. Am I multiplying 4 by 1?
4 times 4.
What place is it in? The 1. In the tens, right? So how many tens do I have? I have 1 tens, right? So basically I have 10. I'm multiplying 4 times 10. So I end up, 4 times 10 is what? 40. So when you add it, you get 48, right? This is the detail. This is just the detailed version of why the multiplication works. Now watch what happens when I use two digits. I'm going to use easy numbers, 2, 2, and 12. So again, this is in the ones and this in the tens, right? So this in the ones and this one now is in what place? The tens. So I have 2 times 2, 4. What is 2 times, am I multiplying by 2 now? By 20, right? Because it's in the tens. So 2 times 20, what is it? 40. Do not mind this part right here. I'm just doing the additions here. Now the 1, is that a 1 or is that a 10? That's a 10, right? So what is 10 times 2? And how about that 2? Is it 20 or is it 2? It's 20, right? So what is 10 times 20? 200. What is 10 times 20? 200, right? Do not get confused. So when I add it up, 4, 6, and 2. I'm breaking it down this way to show you that the placeholder right here is actually saying I'm multiplying by 40 now, so I need that extra space. So 40 times 5, what is it? What is it? So you should get that. Well, no. 40 times 5 is not 200. Oh my goodness. 40 times 5, 0, 200, right? So you do it that way, basically. If I were to add it, 200 will be in the middle over there. But now, the reason why we use that placeholder is because we're multiplying by a number in the tens. So it needs that extra number. It's a little bit difficult to understand this if you have never been exposed to it. But they should have told you this from the very beginning. Otherwise, you're saying, oh, I'm just putting a 0 there. You're really not. It has a purpose of it for it. Anyway, so the other part that I want to show you is where to place a decimal. A lot of you get confused with that. Look at how many numbers we have after the decimal. How many do we have? I want you to circle that number. And then when you get your answer, circle from right to left that same amount of number. 1, right? So my decimal goes right there. My answer is 3,356.5 cubic feet, right? No, square feet, because we are talking about area. So I'm gonna leave it this way because I'm gonna use it later on. So now watch what happens when I add height to this guy. I don't know what happened. Hang on. I'm gonna have to draw another one because I don't like that one. Let's pretend they're the same height, the same length. And now when I raise it, what am I doing to it? I'm adding height, right? When you add height to a 2D shape, you're turning it into a 3D shape, right? Because now it has more dimension, it has more sides and stuff. Yes, those are the ones I use for their classes. So let's say that I added 77.5. Go ahead and multiply your area of the base, which you already found, by the height of 77.5. We already found the area of the base, right? Now we multiply by 77.5, which is the height. All right, so you should have gotten a really big number, but before we actually look at our answers, what you want to do, you want to approximate or kind of estimate what answer you should get. We're multiplying 3,000, right? Essentially, by what number? 77, right? Or 70 per se. Let's say it that way. That means you should get a number that is bigger than 3,000, right? But not too big. So when you multiply one digit number by another digit number, how many digits do you get? 1. Is it all the time? When is it that you don't get 1 digit? About 3 maybe? Because 4 times 4 is 16, right? That's 2 digits. But it really cannot go more than 3 digits because 9 times 9 is 81. It doesn't go above that, right? So what I'm trying to say with that is if you're multiplying a 4-digit number by a 2-digit number, you should get at least 5 digits, right? If you got less than that or way more than that, then that means you did something wrong. Well, it depends because you have decimals. So let's multiply by what? And the decimal was over here for the other one, right? So 5 times 5 is 25. Carry 2. 30, 32, carry 3, 25, 28, carry 2, 15, 17, carry 1, 15, and 1 is 16. Placeholder, that'll be 35, carry 3, 42, 45, carry 4, 35 and 4 is 39, carry 3, 21 and 3 is 24, 21 and 4 is 25, right? And then the same thing follows right here. Is it? So 3 times 1 is 2, and then, oh no, it's 23, right? 23, sorry. So now let's add these. 5, 7, that'll be 18, carry 1, 22, right? Carry 1, that'll be 20, carry 2, and that's 7, 8, and 2 is 10, carry 1. It'll be 6, and 1 is 6, sorry, that was 5, and then 2, right? Is that what y'all got?
No.
Where did I go wrong?
I got. I only got the last 3 numbers right.
All right, hang on. I know a lot of you got them wrong, but a lot of you don't place the decimals in the right spot. So let's make sure, like, I did it right. 0.5 times 77.5. I got 128.75. So there's a 1 right here. Oh, that's because I carried 2, not 1. Okay. There you go. All right, there we go. So again, how do I decide where my decimal goes? You go in circle, right? Circle the numbers that are behind the decimal, after the decimal. So that one and that one, that's 2 of them, right? That means I have to circle 2 from right to left. 1, 2, right there. So it's going to be 26, 260,000, 28.75 cubic feet, right? Oh, dang it, yes. There you go. So my answer, correct? Let's go over another one that would be for triangular prisms now.
I'm not one of this school.
Well, you're not. So let me ask you a quick question here. Which one is the base here? What is the base? Let's say for the third one. 10 times 25. Who says 10 times 25? Raise your hand. Who disagrees? Okay, Soraya, why do you think it's not the base?
I think it's not the base because it's that slanting thing.
The what? Because it's slanted?
Because that slanted part is.
What do you think is the base? 10, I'm not, which one is the base? Which face is the base? Which part of it is the base? Not what measurements, but what measurements? You see the one at the bottom? That's what everybody said, though. What do you say?
10.
What do you think 10 by 10 is the base?
Because if it's just like the 2D, it would just be the flat, the bottom would just be a triangle, and if you raise it up,
Let me model what he just said. He said, hang on. He said you can do that, right? And then I just raised it up. Well, how about now? I can change it in many different ways, right? Hang on. So your idea is that the base is still a triangle even though it's landing on a different side, right? What do we call that figure? Give me that red one. A rectangular prism? Other one. Why do we call it a triangular prism?
Because it has
Well, that's a good observation. We call it a triangular prism because that's the base of the prism. So as a future note, all the prisms are named after the base. So if there's a triangle that has two triangles on each side, those are your two bases, the bottom and the top. It doesn't matter which way you put it, it's still a triangular prism. So good job, Rafael, for pointing out that you started with the triangle, right, as the base, and then you raised it up, and you ended up with the base on top, base at the bottom, and now it's created into a prism. Same happens with this right here. You have a square at the bottom, right? And I just raised it up. It could be landing right here. Technically, you can call this a rectangular prism because the angles are rectangles, right? Or those of a rectangle. But if it was a triangle, it doesn't matter how I land it. It's still a triangular prism, right? So this is important because the formula says find the area of the base and then multiply by the height. So if you find the area of 10 by 25 and then multiply by 10, you're going to get the wrong thing, right? However, if you find the area of the base, which is a triangle, and multiply by the height of 25, then you will get the right volume. It makes a huge difference. So I want you to do the same thing for all four of these right here. Yes, they're not very difficult. Actually, skip number 2. Do number 1, 3, and 4. Oh. There you go. 1, 3, and 4 only. All right, so for this one is volume equals area of the base times the height, right? And I want you to draw this. To find the area of the base, there's a formula, right? Base times height divided by 2 and then times the height. So base is 4 times the height of 6, right? Always highlight the base like it's over there so you know what you're working with. And then times 8, right? So 4 times 6, 24 divided by 2, 12. What is 12 times 8? 96 centimeters cubed, right? That's the first one. The second one will be the same way. Area of the base times the height. Area of the base is base times height divided by 2 times the height. So it will be 4.5 times 5 divided by 2. Oh, wait, I didn't say to do this one, right? I won't finish it because he has too many things. But this one right here, it's easier too. It is 10 times 10 divided by 2 times 25, right? So 100 divided by 2 is 50. 50 times 25? 1250, right? You're not multiplying by 100. You're multiplying by 50. Centimeters cubed. I mean, yeah, cubed. And same with that one. 9 times 12 divided by 2. And then multiply by 18. All right, so for your homework, I'm going to give you a few of these. They are, I'll give you 2 easy ones. They're going to be these 2 right here. The video will be, not the thing. So those are the first 2. And then I'm going to have to go back and find some rectangular prisms. Ooh, a card. Let's use that. I like the little card. These are easy, yes. There are two in here. Well, you can hardly see it.
This is for 250. This is 750. 250. That's 750.
Can you not do the mouse, please? Where's the card?
Right there. It's 250. It's not 7. Right, Mister? 750.
Can you just paste? Why did it freeze? Great. Hang on, this stuff sucks. Yeah, you have homework. This is the second part of the homework. So you have that for both the square at the bottom and in here. And then you have this right here. Have a good one. It's 4 problems total.